Today, I'm going to be covering the research on comparing the use and usefulness of 4 IoT security labels. My name is Peter Caven, and this work was conducted with Zitao Zhang, Xinyao Ma, Dr. Jacob Abbott, and Dr. Jean Kim. So there's been an ongoing U.S. effort to develop a cohesive cybersecurity labeling program for IoT and consumer software. This effort culminated in the release of the U.S. Cyber Trust Mark in July 2023. At their core, security labels are a communication mechanism. They provide consumers with knowledge about a product at that point of purchase, which helps to mitigate a problem where consumers make suboptimal purchase decisions due to the inability to determine a good security quality. Still, even with labels, without a standardized design to make information easily comparable, consumers may remain unable to differentiate between a secure and insecure device. So it's important for buyers to have access to reliable information at that point of purchase. But again, it needs to be consistent and needs to be comparable. Our study will focus on 4 designs, each with their own benefits and limitations. So the first label we're going to look at is going to be the U.S. Cyber Trust Mark, and it's going to act as a certifying seal. This label does not present individual risk factors, as it only indicates that a labeled product meets a baseline standard. It's going to be the simplest approach to mitigate that information asymmetry. We will refer to this label as a binary label throughout the rest of this presentation. Next, we'll look at Underwriter Laboratories' IoT Security Rating Program, which was first introduced in 2019. This label was based on its IoT Security Top 20 design principles and uses an ascending 5-level scale from high to low. And like the previous binary label, this label effectively conveys information without burdening the user with that excessive cognitive load due to the visibility of status. We can refer to this label as the graded shield label throughout the rest of the presentation. In 2020, Carnegie Mellon introduced a standard way for manufacturers to communicate the security and privacy practices of their IoT devices by using its IoT Security and Privacy label. This label presents each individual risk factor to users, and in doing so, it actually may be difficult to use without a comprehensive understanding of the technical information used to build the label. We're going to refer to this label as a nutrition style label. Finally, we have our label based on prior research into risk communication and then also that privacy-related research. This label represents a more obvious multi-layer design as it has clear design language and that the QR code is going to be the same size of that representative label. We're going to call this a 5-lock label throughout the rest of the presentation. So overall, we look to gauge the effectiveness of these 4 label designs on their ability to inform consumers, and we have 4 research questions that we hope to answer in the results as well. So our study was conducted online and asynchronously. Participants were not given any extra information or instructions about the labels. Its goal was to replicate real-world usage and better assess how labels would be used in the wild. In total, there were 8 distinct phases to this study, and the median time to complete was about 17 minutes. Here's an example of phase 3 of our study. On the left, participants selected a product they deemed to be the most secure. And then on the right, we can see they justified their selection and answered security questions about the quality of the product based off of the label they selected. So we recruited 500 participants via Prolific and collected demographic information on income, education, age, gender, race, etc. And then Prolific did provide a representative sample across age, gender, and race for the US, and so we're going to use that as well. As you can see, due to the platform requirements of literacy and computer access, our sample was actually relatively educated compared to the US Census data. We can see that 59% of our participants had a bachelor's degree or higher. So at their core, labels are designed to help consumers make more informed decisions. If they fail to do this, they're not really that effective. We define label effectiveness by their accuracy in the most secure selection, the speed at which they can make that selection, and the perceived security assurances of a given label. So first, we're going to look at accuracy. We can see the results clearly show that users were able to overwhelmingly identify the most secure product using a 5-lock label with an average accuracy across all products of 88%. Both the graded shield and nutrition labels did perform well with an average accuracy of 46 and 52%. The low accuracy of nutrition style label in the light bulb round did bring down kind of that overall accuracy. However, when we look specifically at the thermostat round, we can see that they were actually highly effective at 65%. When we look at the qualitative results, we can kind of tease out the reason for this, and we'll discuss that later on in this presentation as well. The binary label didn't really do better than random chance with an average accuracy across all products about 20%. So not only should a label support accurate decisions, right? It should provide information in a timely manner. Shorter times are indicative of a label that may be more efficient and user-friendly. If the presented information is clear and comprehensible, it enables users to quickly assess the security quality and make a faster decision. So when we look at three of the labels, the graded shield label at 19 seconds, the 5-lock label at an average of 19 seconds, and the binary label with an average of 22 seconds, they're all relatively the same. The only statistically different one is going to be that nutrition style label in that bottom left over there. It had the longest time to decision with a mean time of about 48 seconds. And while it does provide the most information at a glance, it does so in a manner that requires consumers to really read each label and independently ascertain security levels. And we can see just based off of the graph, there's a significant amount of people that took over 100 seconds to make that selection. And then finally, labels should provide assurances of specific security traits. To do this, we asked participants if they felt their selected product provided security features ensured security concepts. Again, specific designs support this better through different usability heuristics such as visibility status or recognition rather than recall. And then as a reminder, we didn't inform the participants about the underlying requirements to earn each label. And then we also assume that they don't have prior knowledge of this information as well. So the lack of transparency is evident with significant uncertainty across all label designs. And even when we look at the nutrition style label that performed better than the other ones, it didn't provide high level of assurances, even though the information was available on that label. So the usefulness of labels is also contingent on the cognitive burden the label places on the individual. We can use the task load index to quantify this burden. We also seek to understand shifts in design preferences in that pre and post study. And then we can tease that out with our qualitative results. So earlier, we measured a label's mental load by measuring the time to selection. Designs that allowed a quicker time to selections were thought to be less mentally taxing. Here we're going to use the NASA TLX to measure that cognitive demands across mental, temporal, performance, effort, and frustration dimensions. We can look at the above table that shows the average across the NASA TLX measures, and then there's a graphical representation of the box and whisker chart below. It's gonna be the same information for both that. Here we can see the binary label, which was touted for its simplicity, was not actually found to be easier to use. Instead, it was seen as the most frustrating and required the second most effort and mental demands. The nutrition style label, which had the highest mental demands, took the longest time to use and the most effort, but it actually resulted in participants believing they had a more accurate selection. And then when we look at the 5-lock label, it just kind of performed well across all TLX measures. So at the start of the study, participants believed the most informationally dense nutrition style label was going to be the best indicator of higher security. At the end of the study, the majority of respondents felt that like the 5-lock label design was able to succinctly communicate security posture. The other 3 labels did see a significant drop in perceived utility. And when we look at the qualitative results to really tease out what those issues were and why there was a change in preference, there's a lot of information here. We're going to provide the highlights, but if you want more in-depth understanding of what the reasons were, you can look at our research paper. So when we look at the top left quadrant right over here, we can see that in the pre-study, 38% of our participants did not actually leverage labels as an indicator of security quality, even though they had that as a viable information. Instead, their decisions were predominantly shaped by a combination of factors encompassing a product's visual aesthetics and perceived functional attributes. In many instances, the absence of functional information drove participants to rely on intuitive judgments and personal preferences in determining the security quality. However, it is noteworthy that specific label designs were more readily accepted as providing that security assurance. So for example, the nutrition style label, while not well understood by participants so early on in the study, was seen to provide security assurance by virtue of being the most verbose. And then when we look at the bottom right, so in the post-study, Again, the nutrition style labels maintain their usability by virtue of information conveyance, but to be fully utilized, it would need the participants to have more technical understanding of the information that made up the label. Participants noted that significant effort was actually needed to compare across products, and so for their accuracy, they honed it on one specific aspect of the label. And when I talked about the accuracy difference between the thermostat and light bulb round, this is where it really came to bear. Participants that would hone in on a specific aspect of the label, such as manufacturing location based in the US as a higher indicator of security quality versus if it was in India or China. And so that's why there was that significant delta or significant change between those two rounds. And then when we look at the 5-lock label, we can see the greatest jump in usability due to the intuitive design and the simplicity and easeability to use a label design using that 5-locks internal grading scale. So security label design should enable consumers to make more accurate, timely choices without overburdening them. Labels ideally would communicate security information efficiently at the time of purchase. Our survey showed that 51% of participants do not actually do prior research on a product before purchasing. So that implies security information should be available on a product at the point of purchase to best inform those decisions. Security is just one aspect that influences purchasing. However, an important implication of our experiment is that simply providing more information does not actually mean more informed or even more secure purchasing decisions. Additional information can actually overwhelm users, leading to increased cognitive load, prolonged decision-making, and inaccurate security choices. This study emphasizes the importance of understanding underlying perceptions, motivations, and behaviors that shape individual responses to security labels. It goes beyond simple design comparisons by examining the cognitive workload and accuracy of those decisions. In doing so, we not only address the content of the label, but also help participants interpret and use that information in the decision-making process. Thank you for taking the time to watch this presentation. Again, my name is Peter Caven, and if you have any questions, feel free to reach out to me. Thank you again.